So a couple of quick examples, because I've got to run to a doctor's appointment shortly. These are some typical soil, fossil soil profiles. This one is so beautiful that it looks very much like a modern soil. We can see the organic A horizon. Here's a leach zone, and then there's carbonate accumulation down here. And this soil was quenched, as it were. It was buried by about a meter of river sediment. And this is another one, a leach zone, and here's a carbonate zone down below. So we were very interested in using soil carbonates to reconstruct paleo vegetation and paleo landscapes. So this is one of the first study that we did. This is Jay Quaid's work in 1989, and we made this extraordinary observation that we had all C3 vegetation, and then we switched to all C4 vegetation. So calcium carbonate is enriched by about 14 to 15 per mil relative to vegetation. So vegetation is minus 10, minus 25. So this is minus 25 vegetation, and this is minus 12 vegetation. So we have switched in this one environment from a pure C3 to a pure C4 world. Okay? This is not in your notes. I'm just going to show you some work that a current student is working on, a guy named Tyler Huth. And he's working on these big boulders that were deposited by debris flows in central Utah. And this is one that got flipped over, not by me, but actually by a bulldozer. And it's turned completely upside down, so we've rotated it in Photoshop. And here's the exposed part. You can see the paleo leach zone, and then there's these calcium carbonates. This rind of carbonate is about a centimeter and a half thick. Okay? So what we're doing is dating the carbonate rinds with uranium, thorium, and carbon-14 dating. And I'm just showing you this, his preliminary profile. So these are about 3 to 500 year time intervals in between. So this is today. This is, we think, is the Younger Dryas, full glacial, and then back into the glacial, but not the full glacial. And we think this is actually in millimeters. So this is only the first 9 millimeters of the thing. We've got to go to about here. We've got another centimeter to go on this rind to get to the next full glacial and back interglacial and so on. So these can give you really wonderful records in the right places. I'm going to speed through a couple of things. This is a recent study that we did in Africa, and again, C3, C4. And the question was posed to me by a paleoanthropologist. He handed me a tool at Olduvai Gorge and said, "Can you tell me if the hominin who made this was sitting in the shade?" I said, my God, you guys ask hard enough questions, but really. And so I said to him, if you can tell me the time of day, I can tell if he was sitting in the shade. Okay? And I won't give you a total solution to that because I don't have enough time to talk about it now, but we did. So I'm going to show now paleo shade, the isotope value of shade. Okay? So, can we quantify shade? Well, let's redefine shade. And like in, beginning calculus, you have to remember what's really is important, the variables. So let's redefine the variables. And we'll redefine shade as woody cover. Maybe we can measure woody cover. Okay? So here's a gradient of ecosystem structure from 1% shade, that bush, to 1% open, that road. Okay? And we're going to use these. Okay? So we've got shade and not shade. So not shade is tropical grasses, and not shade are the C3 forbs and herbs. So like cucumbers. Cucumbers actually grow out here in Africa. Cucumbers are C3 and they're not shade. So we have shade and not shade, and we say, well, we'll use Michael Bird's way of talking about ecosystems, and we'll measure samples in what we call gaps or grass and canopy samples. So we'll measure delta C13 underneath canopy and in the gap. So the gap samples are halfway between canopy overlaps. And we do this for lots and lots of different soils. In fact, about 75 soils around the world. And we don't get a one-to-one line, but we actually get a line that we can quantify. So then we can measure the woody cover. We can measure the woody cover by, it turned out the easiest way turns out to be Google, which we couldn't do 30 years ago, but we can sure do now. And we tested Google versus transects with somebody making a shade, measuring, am I under shade, am I not under shade? And we did up-looking photography, and they all give the same answer. So now we use Google. So here's our 1%, 21%, 99% shade. And we do these for lots of different sites in Africa and elsewhere. And we get all of these soils, and we get a mixing line, basically for from C4 to C3, from 0% woody cover to 100% woody cover. And we can recast that as a probability density function, okay? And so for any delta C13 value, we can calculate the density function of the fraction woody cover. And in East Africa, we've analyzed more than 1,000 soils in different areas related to early human evolution. And so we can quantify this. This shows one site that Naomi Levin, a student of mine, was working on with me in Kenya. And we have two different regions, the Shungura Formation, which is in the axial margin, and the axial center of the basin, and the axial margin. And what we see is over time, we go from sort of a forest woodland to more and more open habitats. And we never see this open grassland environment where the hominins were being found. This is from Lake Turkana, where there's been more than 1,000 hominin fossils found. Like Turkana Boy, 1470, and those guys. And if we look at this over time, both in the Awash region in Ethiopia, Omo Turkana Basin, for individual sites, we can begin to quantify this shade factor. Okay, what was the environment like? And that involves certainly what are the sort of decisions that an early hominin would have to make, And we were actually able to show, this gets back to where was the hominin sitting, we were actually show the temperature distribution of the ground surface through the course of a day for modern environments. Okay, Lake Turkana today, where I work, the ground surface temperature at 2 in the afternoon often is over 60 degrees Celsius. There's nobody out there. Everybody's in the shade. All the goats are in the shade. Hominins are as smart as goats. They were in the shade. Okay? Okay. Well, we had this relationship before. The concentration in the atmosphere is how much the concentration of CO2 contributed by the soil system. Okay? So soil CO2 is that of the atmosphere, and on top of that is soil produced by the ecosystem. And if we know the delta C13 of the produced CO2, the respired CO2, and present in a soil, we can actually calculate, and we can guess, if we can guess this. So we need delta C13 of the soil CO2, which we can get from calcium carbonate because we know the offset. This is the organic matter in the soil. We need to guess this, and that it means is, unfortunately, is the CO2 that we calculate for the atmosphere value is directly proportional to this equation. But it's an elegant equation. Got me 2 NSF proposals funded. NSF didn't fund the really cool stuff, which was the theory leading up to it. But once you say, oh, well, everybody wants to know soil CO2, so, oh, we'll give you money for that. So here's atmospheric soil CO2 history from a variety of methods. Bob Berner's model is this gray method. So this is using boron isotopes, paleosols, stomatas, various things. This is a major problem to certainly to geologists. What is the history of atmospheric CO2 on our planet? Okay, we know that the current situation is not normal. In fact, most of the planetary history, CO2 has been significantly higher than today. Okay, so I'm going to close with that. I told Ming to get the coffee a little early because I've got a doctor's appointment in about half an hour, but I'll be back by noon. And so any quick questions, ask them now. Otherwise, I'll be around. You can get me later.
For your shape proxy, how far back can you apply that relationship?
Only till we really know we had significant we had C3, C4 distributions. So in Africa, back 7 or 8 million years. Okay, we basically before 10 million years ago, all the evidence would suggest that the net primary productivity of C4 plants in the tropics was less than 1%. And so as I said in my lecture a few days ago, we're really in the midst of a really major revolution in ecosystem structure on the planet. One of the biggest, with the grasses just totally taking over the tropics. Because in the tropics, they're estimated to be 50% of NPP, and we've gone from 1 to 50% of this plant structure, which is a very different plant structure than previously. Dave?
Yeah, you talked about using paleocarbonates as a proxy for PCO2. How do you constrain the respiration function, the soil respiration function?
You guess it. You totally guess it. You say, based on my best estimate, I'm going to use 2,000 ppm. So originally in our papers, we used 5,000 ppm, and then Dan Breeker said, I like 2,500 ppm better, and that changes all the values. And there's really no good, we don't have an independent measure of what that value really is. And I really don't have a strong opinion on what value you should use. It's probably between those two values. It's not 1,000 ppm, it's not 10,000 ppm.
But if you knew the general aspects of the climate of the environment, probably could estimate what the vegetation is sort of like.
Right, but what time of this year are the carbonates precipitating? Dan has shown that in New Mexico, it's probably in early summer, and that's the only place where we've been able to quantify it. Tyler is, in his studies here in Utah, is showing in that area it's probably late August, early September. But it's going to be different in different places. So it's probably in the declining part of the growing season as the soils are dewatering and degassing. That's while temperatures are high. All of those three things are pushing carbonate precipitation. And then the other times of the year, we know we get carbonate dissolution in the upper part of the soil. All these soils are leached, the upper 30 centimeters. There's no carbonate in them at all. And if we collect dust, we get a little tiny bit of carbonate. So all of that dust that is landing on the soil is dissolving. Okay? Yeah?
So, Thure, for the model with the shade and the copper, how do you, for this to correct for C3 grasses and shrubs, is it that you have to do a modern calibration?
You have to do a modern calibration.
Okay. So if it's an ecosystem that's that doesn't really have a great modern, you'd have to do it for every area.
Yeah.
Apply that model.
Well, what we've done, the model that we have is tropical, is from about 20 degrees north to 20 degrees south. Okay. And it's Australia, Africa, Brazil, and when we start picking things out, it doesn't change much.
Okay.
In fact, somebody kept saying, well, we don't like your results because you're not giving what we want, so throw out these ones. So we said, okay. And then he said, oh no, we're still not right. Throw out these ones. So finally we said, okay, we're going to use only the soils whose name starts with B and S. We call this the BS function. And there was only two soils left. Only two soils left. And we got the same result.
Okay.
So the BS function is the same as using a full data set.
Okay.
Sorry we can't get the numbers you want. But, well, the problem with this site is this particular site is it's one of the most C4 dominated ecosystems of all of the hominin sites, and he wants it to be a pure forest. You can't do it. So, okay. So Lisa is going to carry on. Pendle is going to carry on at the end next.
10:30?
At 10:30, yeah, I'll give you a couple of minutes, and go for it.